Welcome, listeners. This is Sanjog Aul, your host, and the topic for today's conversation is enabling real-time analytics. Joining us today is Scott Zoldi. Scott is the Vice President of Analytic Science for FICO. Hello, Scott. How are you?
I'm doing fine, thank you.
Thank you for joining us. Now, as part of our series in memory computing, we are talked extensively about its potential and whether or not it's ready for the mainstream. And yet one of the most interesting use cases involves something that goes beyond just technology or architecture, and that's enabling real-time analytics. So IMC or not, this is something a lot of organizations would like to tackle. And today we want to discuss how they might approach that and what immediate impact doing so could have. So, Scott, the first question for you is, where so far have organizations struggled to attain genuinely real-time analytics?
Generally, with respect to organizations taking on real-time analytics is around the technology stack. And so, one of the things that they've struggled with in the past is whether or not the data that they need to make that real-time decision in an efficient fashion. So as an example, FICO developed a set of models called the Falcon Fraud Manager models. And in those models, we leverage something called transaction profiles, where there's data that is efficiently condensed in terms of small records that would have these recursive variables that would summarize transaction histories. And so Falcon is a product that's been protecting cardholders in the U.S. for more than 2 decades and leverages this concept of a small transaction data record. Those companies that don't do that try to go and have a real-time on-demand access, let's say, to all the transaction history to make a decision, typically struggle with the ability to do that in real time because of the data access requirements. And so when we look at real-time analytics, companies like FICO focus very strongly on what we call streaming analytics, and that's really this concept of data very efficiently in terms of a single transaction profile, let's say, that allows us to get access to the entire history of transactions in a very fashion, and that enables real-time analytics. And those that don't use tricks like that typically do struggle.
Now, you mentioned about when we look at the real time as a phrase, how close are we to that real time, and how close to real time are the majority in getting insights from big data and analytics endeavors that they're making?
So in terms of real time for things like the fraud solutions that are out there in the market today that the banks leverage, a real-time response from an analytic model would be about 10 milliseconds. And with the newer technologies around NoSQL databases, it's certainly possible to go sub-millisecond decisions in terms of making those real-time decisions. So that's roughly the time span. So, for example, here at FICO, when we develop a fraud model, we're returning real-time decisions and scores based on tens of milliseconds in fraud, and faster than that when we look in areas such as cybersecurity, where it's very important that those decisions get made in a timely fashion, so that people that need to make a decision or monitor what's happening at the edges of, let's say, networks can be notified to abnormal events and then try to remedy those situations.
Now, what have been the challenges in real-time analytics implementation thus far, whether you see it within FICO or outside, and what's the need to accelerate that process even more?
I think some of the challenges have really been around adoption of newer technology. So today there are things such as Storm and Spark and other in-memory databases that are available for making decisions in real time. And typically what happens is one has a situation where you need to decide the level of complexity, the scoring, or the calculations that need to occur. So, for example, we develop models that have a number of these transaction profiles, and that leads to issues with what we could call contention, where there might be multiple threads all trying to process a large transactions in real time, all utilizing shared memory objects. And that means that there's contention for those pieces of information that are being sent. And that's generally, that can be a tuning exercise where if you are leveraging things like a NoSQL database coupled with Spark or Storm, you need to look at, having the growth of compute nodes and the right amount of contention remedies in place. And or one moves away from things like some of the big data architectures and looks at some of the memory fabrics that are out there that allows access to this data to be done completely in memory without the NoSQL databases that may have a combination of a cache and a disk persistence, and to get the optimal speed there. But that's generally going to be the issue for the types of real-time analytics and real-time decisions that are relatively complex from an analytics perspective, because there's typically going to be a lot of shared data in these decisions, and then contention for those data resources in a very short period of time when that real-time decision needs to be made.
So we understand the value of real-time analytics, and yes, perhaps it might be providing some incremental value, but do you think this could be a source of a competitive advantage?
Absolutely. From my perspective, and potentially I'm biased given the 15 years that I've been at FICO, real-time analytics is definitely a competitive advantage. And so in the fraud space, for example, you have an opportunity to stop the fraud transaction before it goes through, let's say with a payment card. In a cyber application, you have an opportunity to see that there's a breach occurring or there's a command and control set of messages that are going out between your organization and, let's say, a botnet out there, and you stop data from within the organization before it's too late versus looking at a back-end analysis later to know that your data has left your organization. Or there's many use cases where we want to make a real-time marketing offer to a customer as they walk through a store or based on things that are associated with their most recent spending activity. And the more that we can bring those decisions, right, or those offers or those notifications to a customer or protect our defenses from a fraud or cyber security perspective, bring that to the real-time event where we need to make the right decision at the right time. That's the competitive advantage. And if we don't, then we're in a situation where we'll see, fraud being committed and have to deal with that after it's already occurred, or situations such as breaches where data has been stolen from an organization and the opportunity to potentially stop that wasn't taken because there wasn't this real-time analytics to detect that event.
Now, to that end, how can IT help? How can IT help drive this advantage?
From an IT perspective, a big part of driving this is essentially focusing on making sure that we have the right sort of architecture of these systems understood. As an example, the topic of contention for certain memory that is associated with let's say, an analytic model. That might be a tuning exercise where some very specialized sort of knowledge of how to leverage, let's say, Storm might be something that would be used, or it might be something where we'd say, listen, we are not going to look at distributed computing. We need to have an architecture that involves the shared memory fabric because we have certain pieces of information or calculations that are going to have very, very low latency. So from a key perspective, a very strong knowledge of what the options are in terms of very low latency access to data, or more complicated NoSQL databases that have a very efficient memory cache coupled with a persistence layer to disk, and understanding those systems very intimately to help make the right sort of decisions around the latency of accessing this data in a real-time scoring application. It is really essential, and that's probably where most of the applications struggle. But there's lots of options out there, and it's really around getting sufficient experience with the pros and cons of different types of technologies.
So as an industry, would you say financials is one of the key industries which will be able to benefit and get the full benefits out of it? Or this is going to be socialized among other industries and everyone can benefit?
Well, certainly the financial industry has a head start with things like the Falcon product that is monitoring for credit card fraud. But other industries certainly will benefit also. And one of the most interesting things that I'm involved with in the last year has been this concept of cyber analytics, essentially bringing a different breed of analytics to look for cybersecurity issues. And this is one that applies to everyone and every company out there in terms of protecting your company from cyber threat. And in those situations, today, a lot of the signature-based methods that are out there from a cybersecurity perspective are failing. And this is where more advanced sort of analytics, similar to what we do in the fraud space, are really going to take hold and be a differentiator to protect companies. And that, it affects every one of us that has a computing system related to our companies and related to our personal lives. And I think it can be very, very much widespread. In addition to that, the same technology that we're talking about here is really, from a FICO perspective and from a personal perspective, it's key to the whole problem of the velocity. We talk about the big V's of big data, the velocity of data that's being sent through systems. And I think as we look at our daily lives and all the data that we produce, having an analytic system that can go and make a real-time decision and provide the right sort of feedback to a user is going to be more and more expected by everyone that uses these mobile devices and computers, and having it be relevant. So I think we're going to see it take hold very significantly. And I think a lot of the newer technologies around self-learning analytics and topics like that will really become part of the next decade of kind of analytic advancement in terms of real-time decisioning.
Let's take a quick break, listeners. We'll be right back and discuss the current state of adoption of real-time analytics into the organization and any related challenges we may be facing. Please stay tuned, listeners. We'll be right back.
HP is proud to sponsor this program. Find out how the HP as a Service solution for SAP HANA can help you gain instant, impactful business results without capital investment by logging on to hp.com. Transform information into intelligence and a competitive advantage with a full spectrum of SAP HANA products and services from HP, a global SAP hosting partner. You are listening to CIO Talk Radio Viewpoint.
Welcome back. So, Scott, how far away most of the organizations are from adopting real-time analytics into the organization? And are these adoption challenges, would you say, due to any infrastructure shortcomings or issues? And if so, would you think something like in-memory be a viable fix?
In terms of many of the organizations, I think there is a mind shift that has to occur. And so, as an example, in the fraud area, it was a natural area for real-time analytics to take place. So, for example, when you swipe your credit card and there's an authorization that has to occur, and the bank's responsible for making that authorization in a short period of time, that we don't sit in front of the payment device waiting to purchase our groceries. And so there were really near-term, real requirements about making decisions quickly and facilitating this real-time analytics. In other areas, I think there's still work to be done within organizations around making sure they understand, the business value for some of those decisions in terms of, why do I need to collect this data and why do I have to return a decision, let's say, on a tweet, or potentially why would I want to respond so rapidly to, let's say, a customer inquiry? So I think there's a piece of it which is making sure that people understand that it is going to be a differentiator to their business. It's going to be a differentiator in terms of how customers feel they're being accommodated and, their needs being addressed. From an IT perspective then, and from a data collection perspective, there are challenges in terms of making sure that the frequency at which data is received by organizations is sped up. Things like an hourly batch is not going to be sufficient if you need a real-time decision. And so, there are some of those infrastructure changes that have to occur. I think those businesses that do that first will obviously be the kind of the innovators in the space, and will have the more competitive projects and offerings. And I think that will be part of the transformation we'll see. But, one of the first steps is to get organizations and businesses to think about how they can use that as a differentiator.
So would you think that in-memory, the new paradigm, if you will, of computing is going to, or it could perhaps be a savior or provide that assistance in making this a reality?
Absolutely, I do. I mean, I think it's become much, much easier with a lot of the open source that we have today in terms of in-memory computing and big data infrastructures to very quickly bring up little proofs of concepts of how these systems would work. And so, I think that's going to be one of the big drivers, is that things that used to be challenges that we would work in, high-performance computing labs maybe 15 or 20 years ago are now pretty routine in terms of the tools that we have from a big data perspective to solve. And that's great, because that's really that ease of implementing and trying these things out from an in-memory and real-time analytics perspective is really going to be the things that are going to drive the innovation in the space. So I think we're at an interesting point in computing where things that were very, very difficult before big data and some of the open source tools are now relatively easy, and that's going to open up a huge landscape for innovation and new creative solutions using this in-memory computing and real-time analytics.
Now, taking to the next level, would you think that analytics as a service is something you can foresee becoming a viable option?
Absolutely. There's a lot of focus on analytics as a service. So as an example, from this historical precedent, Falcon being one of the oldest, continues to be one of the most successful fraud solutions with real-time analytics. These are systems we would install at a customer premise. But now we're bringing more and more of this real-time analytics onto cloud infrastructures to enable the real-time analytics as a service. So I think that's the natural next step. It's something that FICO is actively looking at in terms of some of the same technologies that we've developed in Falcon and in our cybersecurity solution, bringing it onto our own FICO analytic cloud and enabling those analytic services in terms of real-time analytics. So we should be able to see more and more of that. And I think that's another way that we're going to see innovation in this space, because it further removes kind of friction from people trying out the technologies and doing some proof of concepts around using real-time analytics to change their businesses.
So when you look at the type of provider solutions or vendor solutions that are available, what specific conflicts or challenges that you think are surfacing, and how do you go about, or an organization goes about, identifying or determining if they are a good candidate for such a solution?
It's a great question. I think one of the challenges is really making sure that you have that the different solutions that you have out there have some level of pedigree in terms of, the analytic techniques and what are the pros and cons of using them. So, for example, there are enough companies and services that will allow you to have access to data that you would persist within memory. But even if I have access to a transaction history in memory, it still may not be fast enough for the type of decision that I need to make. So I think that the key sort of differentiation is, as one looks at the technologies and vendors that are out there, clearly define what the problem is that we want to define from a real-time analytics perspective. If it's an analytics score, then there'll be a lot more that one needs to do with respect to a pedigree of streaming analytics experience and effective use cases out there. I think without that and without looking at sort of this reputation and this credibility, it's going to be a little bit difficult. And then, one might find that projects are deemed failures, but they're really not. They wouldn't be if different technology decisions were made or different vendors are chosen that have this pedigree of applying these streaming analytics techniques. And that's probably the biggest piece, is to find that right vendor that has that experience, that has solutions in production today, have referenceable sites, and asking, does the real-time analytics application that you're developing, does that fit or mirror some of the use cases and successes that these vendors have had in the real-time analytics and decisioning space.
Now, as a last question, how so far has real-time analytics through the use of in-memory computing been manifested, and what advice would you have for someone looking to adopt something similar?
Today, the biggest use cases have really been around addressing the velocity piece of big data. And these are really interesting areas because these are situations where you may decide that the data that you see in real time may or may not resemble historical data. You may or may not have, let's say, the outcomes or tags that you'd want to develop a real model. Or you may just say it's too non-stationary. And that's a whole class of problems where the in-memory and real-time analytics is just essential because it's a class of problems where the models need to self-learn, which means that we're not going to have scientists that necessarily pour over loads of historical data and build static models that would be used, or rule sets that would be used in these production environments. But it would be a class of problems where the analytics itself, the real-time computing is learning relationships in real time because those are shifting so rapidly. I think today the best use case for that and the best examples of that is our cybersecurity challenges that we have with respect to command and control activity and malware. Because of the very advanced adversaries we have in those spaces in terms of their technical prowess and the amount of change that we see there, those are going to be the best sort of use cases in terms of making an adoption and trying to mirror, some of that scenarios where, you may not have historical data to build these applications, or you may need the application to learn in production as data streams by.
Once again, thank you, Scott, for sharing your thoughts and insights in our Practitioner Viewpoint segment.
My pleasure. Thank you so much.
Thank you so much again. And listeners, I invite you to find more conversations about in-memory computing as part of our series at talkradio.com/in-memory computing.